Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of electronics and we are discussing the printing electronics. In the last lecture we have discussed the type of printing technology. In the first we discussed the contact printing and in the continuation of that we will discuss the other form of the contact printing, in which we have another printing technique is the micro contact printing, which is mu CP, means a conformal contact of pre-patterned elastomeric stamp with precise control and alignments to the target surface on the micron scale is the key requirement for successful transfer of the structures. In this technique, a master mold is developed using conventional microfabrication or by using the photolithographies, and the multiple copies of that stamp with the desired structures are reproduces, and then it is used for the further fabrication of the different type of devices. So, a moldable and elastomeric material is usually used to develop the stamp, which is flexible, so that it can be mold, or it can be for like a flexible type of material we will take, which can easily be casted into the master mold and it is delaminated without causing any degradation of the micro scale structures on the stamp surface. For this, just we use poly dimethyl siloxane, that is PDMS, is the frequently used elastomer due to its extraordinary properties as compared to the other elastomers, such as we are having a polymerides and the cross links novalic resin. So, PDMS has few distinguishing properties such as comfortability to the large areas. Moreover, it is having the deformable to mount on non-planar surfaces also. Elasticity for easy release. It is also a isotropic and optically transparent material. So, we will use this material for the fabrication of the micro printing modules. So, low surface free energy, chemically inertness and durability for the multiple uses make PDMS as a attractive candidate for the purpose of using it as a stamp, and that stamp will be used again and again for the fabrication of the devices. So, micro contact is an effective rapid prototyping technique for preparing the substrates and patterning a wide range of materials that are sensitive to the light and chemical agents. So, the lower surface energy is offered by the PDMS stamps due to the elasticity of the siloxane chain and the lower intermolecular forces between the methyl group promote the peeling and stamping capability, which are ideal for the micro contact printing. Similarly, the surface energies of the stamp and the target surface play a significant role in efficient transfer of the ink. So, for instance, if you take the higher energy of PDMS, stamp is desired for the pickup of the ink from the donating surface, whereas higher energy than the PDMS stamp is desired for receiving surface to complete detachment of the ink. So, to avoid collapsing of the stamp during the peeling or during the capillary action, so during inking the surface, a specific ratio of the height to the width of the features on the stamp is required. You see on the screen that this is the method by using this, we print by using the printing technology. You see, PDMS master stamp has been prepared. Now the pouring the ink which is in the form of the solution on this PDMS master stamp. After that, now this PDM is inked, so it is called the inked PDMS. Now we have the patterned surface, and that surface is used. So robustness of the stamp by having the sufficient flexibility and mechanical strength for maintaining the dimensional integrity of the printable structure is of the great importance. So we choose PDM so that we can have the good flexibility as well as a good mechanical strength. Elastomeric properties of the stamp material enhance the efficient ink delivery by providing a good interface between the stamp, ink and the target substrate. So the two important point is there. First is it is having a flexible, moreover it is efficient to deliver or just to interface between the stamp, ink and the target substrate. Submicron scale is challenging to reach as due to the elastomeric nature of the stamp. It tends to collapse and non-contact areas of the stamp also interface with the substrate, leading to the uneven printing. Beside the printing tool and processing conditions, chemical composition of ink is also contributes to the micro contact process. For instance, if we take the polar molecules are challenging to print with the stamp because of the hydrophobicity of the PDMS. Therefore, treatment at right condition of the PDMS stamp is central for stamping such type of material. So similar challenges faced by the flexographic technique is micro contact printing, as diffusion of the molecules in the unpatterned area of the stamp broadens the feature size and thus resulting in the unwanted printing or the stamping of the material besides the intending structure. Means sometimes the structure may be disturbed if the ratio is not accordingly. So repeated use of the same stamp results in swelling due to the absorption of the ink and result in deterioration of the micron scale structure on the stamp. So a proper check and observation of the stamp are needed because the continuous use can cause pairing, bulking and roof collapse of the microstructural pattern upon the physical contact. So therefore, reproducing the similar structure on the target substrate, full operation conditions need to be explored, considering especially the applied pressure, peeling the stamp from the master mold, polarity of the molecules and so on to guarantee uniform printing. Another type of printing technique is the nano imprinting, that is also known as NI. That is, the name suggests, it produces the structure at a nano scale by using the imprint approach. Nowadays the devices are going to be miniaturized, so in that we use nano imprinting. So nano imprinting uses mechanical and physical deformation of the wet layers through molding accompanied by the different thermal procedures. So NI operating principle are quite straightforward as against the micro contact imprinting. NI uses a mold, and that mold having a nano scale structure and that are developed through the standard clean room processes and is pressed against against a uniform coated wet surface at controlled pressure and temperature. So this we will use for the printing the nano devices. A thin residual layer of the polymeric material is intentionally left underneath the mold that is act as a soft cushioning layer and prevent direct impact of the hard mold on the substrate and effectively protect the dedicated and delicate nanoscale features on the mold surface. So, in this we use a resist filling and demold characteristics are the two primary and critical processing steps affecting the print quality throughout and give the throughput. Now, controlling the pressure precisely is central during the demolding process, which helps in maintaining the imprinting pattern at the desired dimension. So, whenever we are preparing a devices, so we keep in the mind that the how much pressure we are giving just for the fabrication of the device. So, various approaches are adopted for executing NI processes, for which we use a thermal, ultraviolet, step and flash. Moreover, we use a roller imprinting also. They are all selected on the basis of type of the material and processing condition, and what type of ink we will use. We prepare the mold according to the requirement. If we talk about the UV NI process, transparent medium is required for allowing the UV light to prevent through and in situ centering of the imprinting structure. Means we just take the on the spot printing, and that should be checked continuously. And UV in is thus considered the most reliable and robust approach among the practiced NI procedures. So, common materials for the molding in the UV in are the quartz and silica. These two materials are used for the preparation of the UV ion. It should be transparent, so we use the quartz and silica, which are molded by using the very high resolution electron beam lithography techniques. So, UV NI process molds prepared by using the quartz and silica by using the electron beam lithography technique. You see on the screen that we are having a substrate and the mold has been prepared, that is a UV curable. Now we are having the pressure, temperature maintained for the imprinting, and the last you are seeing then the pattern substrate is prepared on the substrate. So, by using this, by using the mold, we can prepare the desired structure on the substrate, and that can be used for the further devices. So, the NI process is ideal for a single layer structure, as perfect alignment at the nanoscale on the multi-layer devices is a challenging task. So, most of the time when we just use a single layer structure, then we use the nano imprinting. So, as a final goal to transfer the NI process on a 2-hour manufacturing, introducing the multi-layer steps and misalignment of the stamp during the imprinting needs to be taken care of. Another type of printing is the transfer printing. That transfer printing is relatively a new technique to fabricate the flexible electronics through the physical transfer of the prefabricated structure using a stamp. In this we use the structure. So, microstructure is the shape of the wire or the membrane developed using the standard photolithography processes in the clean room, etched underway, and then used as a stamp to pick and stamp on a target surface. Means we just use the stamp, we put the stamp and we remove the stamp. First the stamp has been prepared in the clean room or etched underway method, so that it can be used again and again. Transfer imprinting can be executed in the two ways, such as the direct transfer or the stamp assisted transfer. So, the transfer imprinting, we have the two ways. Number one, direct transfer, or second is the stamp assisted transfer. In the direct transfer, an adhesive coating is performed on the receiving surface and the donor wafer is directly contacted with it. After releasing, the structures are transferred to the flipped surface on the target surface. Whereas in the case of the stamp assisted transfer is completed into the two step. In the first step, microstructure from donor substrates are picked up the stamp and the stamp is contacted with the target substrate, thus transferring the structure with the top process surface facing the upward. So, elastomeric stamp usually developed by using the PDMS is used, and in the transfer in imprinting where the viscoelastic properties of the stems are exploited to detach the fabricated structure from the donor surface and place the deterministically on the second substrate. So, this technique is deal for developing high speed electronic devices on the unconventional surfaces by merging both the organic and inorganic based material. So, the heterogeneous integration of these dissimilar materials helps in reducing the cost and maintaining the reliability of developed electronic circuit and the system. Moreover, we are having the lower cost which comes from the large area processing units such as the inkjet printing for electrodes and interconnections as well as insulator layers, where the high mobility semiconductor layers are integrated into the discrete circuit and or into full circuit through stamp assisted transfer technology. So, this is an effective approach towards the manufacturing of high end devices on the large area as a state of art processing of electronic grade silicon and other compound semiconductors in the clean room constitute high level of purity, surface smoothness, control over crystallinity, doping level, types resulting in the high carrier mobility without disorderness, without disambiguity. We can prepare the devices by using the transferred imprinting. Now, you can see on the screen that we are having a substrate which is having a SiO2 layer, silicon wafer we use as a substrate, then just we put silicon oxide layer on it, etched pattern has been done. After that, you see in the second diagram PDMS stamping has been printing, peeling off, you see now stamping on the target substrate. Now, after that, from the stamping we can transfer the pattern on the substrate and finally we can get the various electronic devices on the substrate. So, this is the method where we can get the circuits by using the printing technology. So, the structures are developed and finished in the clean room processes and under etched afterward to release and be ready for PDMS transfer. Now, in the figure we have discussed the steps which is involved in the transfer in printing approaches. So, here the structure which having the shape of the wires which are released from the underlying layer using the relevant agent. So, tetrahedral point are designed as per the dimensional requirement and are sufficient enough to keep intact the release texture with the donor wafer before contacting the PDMS stamp. So, the dimensions of the tetrahedral point is essentially the useful for efficient transfer, especially for the structure with the dimensions in the micron scale. So, the conformal contact of the soft elastomeric stamp having the surface activated temporarily through the oxygen plasma with the microwave or the micro ribbons guarantee the efficient pickup. So, the wires attached to the stamp surface and when peeled back retrieve the microstructure with the fast speed and enhancing the kinetic control of the adhesion. So, we require the wire shape and we require the other type of microstructure that will be imprint or that will be on the substrate by using the transfer technology. So, the rate dependent adhesion and the printing of the solid structure with high peel velocity and low stamping velocity have been investigated by using this method. So, the mechanics of the kinetic dependence of switching of the adhesion between the microstructure and the stamp has its origin in the viscoelastic response of the elastomeric structure, and moreover we are having a PDMS in this case. Adhesiveness stamping like this is a very valuable for wafer based microstructure printing to operate it from moderate to the high temperature. So, that we have discussed like that we are having the etched pattern silicon layer. Similarly, we have this type of PDMS stamping and that will be used. Now, further we will discuss the comparing contact printing technologies. Up to now, we have discussed the various contact printing techniques, and these having the various mechanism and features and the challenges that we will discuss one by one. First is the screen printing. If we talk about the screen printing, then it is most used and mature printing techniques, planar or R2R system, speed and versatile. What are the challenges in this screen printing? It is hard to clean, solvent deteriorates, mask patterns we are having, high resolution of uniform line patterns are not possible under the 30 micrometer. So, unfeasible use of the low viscosity link to prevent spreading and bleed out. So, material wastage is most common in this type of technique. Another type is flexography. It is high speed printing process and low cost pattern, high flexible, low pressure printing, and many more we are having in this. But what are challenging, it is a halo effect pattern with excess of the ink due to the printing plate compression to the substrate despite the low pressure applied. Another is the groove printing, which is having a high quality pattern in a cost effective manner, and moreover challenges are that cylinder life and high cost demanding and careful optimization of the process is required. So, these are the another challenges. In the soft lithography method, this is also one of the technique that is having the high quality, convenient and effective method mostly used by the biological sciences, but there are challenges, proper adjustment of the surface energies for efficient transfer to the substrate to be printing, and moreover it is a common swelling of the transfer material, and there are the other methods which are very useful for the electronic printing. Thank you very much.